Hello everyone, this is Akansh Suman here. Now we are going to solve the questions based on Porter Governor power. That means we have to find out the power of the governor, power of the Porter Governor. What is given in the question? But before we start the question, tell me the definition of the power of the governor. The work done on the sleeve to change its equilibrium position for the fractional change in the speed of the governor. That is the power of governor. We have calculated the formula for power of Porter governor, but when there is a decrease in the speed of the governor, when there was decrease in the speed of the governor, in the question what is given for Porter governor, the mass of the sleeve and the mass of the ball are 200 kilogram and 50 kilogram. So I'm writing here the given data, that is capital M is, that is the mass of the sleeve, that is 200 kilogram, and the mass of the ball, that is 50 kilogram. If the height of the governor is 50 centimeter, then the power of the governor for the 3% increase in the speed. What it is saying? 3% increase in the speed. If there is an increase in the speed, what would be the sleeve movement? You all know very well. We have calculated the power of the governor when there is a decrease in the speed of the governor. But I already told you, if there will be an increase in the speed, what would be the formula then? I already told you in the conceptually, I already told you in the power of the governor when we discuss it before. Okay, but in the question we will see again. So the power of the governor, we all know that it is the effort of the governor multiplies sleeve movement. First you need to know the basic formula, that is effort of the governor and the sleeve movement. Okay, and what is the effort of the governor? Because this is a Porter governor in the question, it is given that this is Porter. For Porter governor, effort is E by 2 is equal to Cg M plus M. What are the assumption? All the links, all the arms are having equal length. Okay, and there is no offset. There is no offset of the arms. Okay, that means they both are pivoted at the spindle axis, that means the axis of the governor. So that is the Porter governor. If you know the diagram, that means I'm just drawing you roughly. This is the basically the Porter governor that you send in the figure. This is the Porter governor, and this is the arm which is pivoted at the spindle axis. Now see, Cg M plus M, you can calculate here. What is the value of C? In the question it is given that C is fractional change in the speed, which is given that 3%. 3% means 0.03. That is a fractional change in speed. So I'm just writing here. G is not given, so I'm just assuming this is 9.81 multiply 0.03 multiply 200 plus 50. Okay. Now when you calculate this using calculator, you will get the value 73.575 Newton. Okay. Now we have calculated the effort of the governor. Now we just need to calculate the sleeve movement. What is the formula for the sleeve movement? That is important. Sleeve movement, we all know the sleeve movement formula. However, we have calculated the sleeve movement in the last lecture. In the last video, we have derived the sleeve movement formula when there is a decrease in the speed of the governor. But here it is saying there is an increase in the speed. If there is an increase in the speed, the sleeve movement would be like that. This would be the movement like that, sleeve movement, because there is an increase in the speed. Okay, if there is an increase in the speed, we all know that the sleeve movement would be 2h multiplied 2c upon 1 plus 2c. I am considering 1 plus because there is an increase in the speed. In the video, when we have discussed the power of the governor, we have derived the formula by taking an assumption that there is a decrease in the speed of the governor. So that's why there will be a sleeve movement would comes out that 2h 2c upon 1 minus 2c. But here in the question it is saying that for the 3% increase in the speed. So when there is an increase in the speed, sleeve movement would be like that. Okay, so that would be the slew moment 1 2s 2c upon 1 plus 2c, plus sign will be there. Now we just have to put the values, that is 2 into height of the governor is given in the question, but it is in centimeter. You must have to convert it into meter. Don't forget to convert into meter. Unit must be same. 0.03 upon 1 plus 2 multiply 0.03. Okay, you just need to calculate. Is using calculator you will get the value of multiply 2 multiply 0.5 multiply 2 multiply 0.03, and you will get the value that is 0.056. 0.056, that would be in meter. Okay, this is in meter because we have to calculate the value in power of the governor in terms of joule. Joule means Newton into meter. Okay, so that's why we are calculating the slew moment in meter. Okay, now we have calculated the effort of the governor as well as we have calculated the slew moment. Now we just have to put those both the values in the equation of the in the power formula, and finally we'll get the answer, that is P multiply E by 2, and E by 2 we have got 73.575 multiply the slew moment 0.056. So what is the answer? You will get 73.575, and that would be 4.164 joule. Either you can write it in joule or you can write it in Newton into meter. Okay, this is not Newton meter per second, this is the Newton into meter, because we have done work on the sleeve. Okay, there is a work done on the sleeve. So that is the answer, 4.164. You will get the answer. I hope you will be able to understand how we get the value of the power. Now in the question it is important how we have put the formula for the slew movement, because 2s 2c upon 1 minus 2c when there is a decrease in the speed, but in this case there is an increase in the speed, so we have considered plus sign. Okay, and you all know that the formula for the effort of the Porter governor, that is Cg multiply m plus m. Assumption is what? All the arms are equal length and they are pivoting on the axis of the governor. These are the assumption you must remember. Okay, so I hope you will understand the solution of that question. Thank you.